Section 15.2, oxidation numbers. Video problems 92 and 93, honestly, take a look at these rules and then just go on over to the video problems. I'm going to keep yakking, but you're probably better just to go on over. All right, so let's take a look at this. So what are oxidation numbers? They're basically a way for us to have electron bookkeeping. Okay? They're not the charge. It's not the same thing as the charge. Even though it seems like it, it's not. It's if we were to assign electrons in a molecule, this is what we would do. All right? We're keeping track of the electrons. Now we do that in order to figure out what's being reduced and what's being oxidized. All right? So we do follow these rules. Now these rules are on your pink sheet, but it's best to memorize them for AP. And after you do a bunch of these, you'll be fine. All right? So let's go over the rules. The sum of the oxidation numbers in a molecule is always equal to 0. Okay, so in other words, like CO2, that's a molecule. The oxidation number or oxidation state of oxygen plus the oxidation state of carbon is going to equal 0. So this is going to equal 0 all the time. Okay, now for a polyatomic ion, it equals the charge. So here's a polyatomic ion. So in this case, the oxidation state of the oxygens plus the oxidation state of the sulfur will equal -2. The oxidation number, same thing. The oxidation state of an element is 0. So sodium has an oxidation, sodium solid has an oxidation state of 0. Hydrogen gas has an oxidation state of 0 because that's how hydrogen is normally found. All right, and let's throw another one in there. Oxygen gas, 0. All right. The oxidation number of a monatomic ion is equal to its charge. So for that, what we're saying is like sodium plus has an oxidation state of +1. Right? Aluminum 3 plus has an oxidation state of +3. Right? In compounds, the oxidation number of group 1 metals is +1. Group 2 metals is +2. Again, it sounds an awful lot like the charge, but it is not. All right. In compounds, fluorine is always -1, never an exception. Fluorine is -1. All right. Other nonmetals in that group 17 are -1, except when they're with oxygen or fluorine. All right. Oxygen is usually -2, except when it's with fluorine. Okay. And then hydrogen, when it's with a nonmetal, is +1. When it's with a metal, it's -1. So it depends on what it's with. Okay. At this point, I would say just go on over and look at the video problems, and I'll go through a bunch and I'll mention all the rules. Okay. Yeah. Hold on a sec. Let's talk about this down here. So oxidation numbers, we use them to determine oxidation and reduction. We've sort of already seen that. And we can talk about that. We'll talk about this more. But let's talk about this idea of reducing agent and oxidizing agent. So here, zinc, it's an element, 0 oxidation state. Chlorine, it's an element, 0 oxidation state. So on this side, chloride is -1. Zinc has to be +2 because this has to add up to be 0, right? So if I have -1 here and I've got 2 of them, that's -2, so this has to be +2. Right. So now let's define a couple things. Right. Zinc is going to zinc 2 plus. How did it do that? Well, it lost 2 electrons. So here, electrons of the product, that means that it is being oxidized. It is the oxidation reaction. Okay. So chlorine is going to 2 chlorides. We do that by adding 2 electrons. So that's the reduction reaction. But what you need to know, I'll do this in orange, if I have just some zinc metal that's set on the table, so I got zinc metal on the table, will it automatically become zinc 2 plus? No. We need this chlorine to be, why aren't you cooperating? We need this chlorine right here to be brought up to this zinc for this to happen. So that chlorine caused oxidation. So we call the chlorine the oxidizing agent. Okay. Now, and to be clear, the chlorine is what's actually being reduced. Okay, so the chlorine is reduced. Now, the zinc, we know that the zinc is oxidized, and it causes reduction in chlorine. So the zinc now is the reducing agent. All right, now go look at the video problems. Hopefully you sort of stuck around after I did that. Whoops.